Okay, so let's just do some more examples here. Okay, so here you're reading the question, and this question we've talked about a little bit before, the probability of the proportion of people using marijuana in the past 6 months is 20%. Assume that it really is 20%. And we are going to take another sample of 100 U of C students. Okay, and then we can talk about what we can expect. So what is the probability that the percentage of this new sample will be between 18% and 23%? Okay, so here what we're saying is let's assume that the proportion, the true proportion, is really 20%. What's the probability that our particular sample will range in between 18 and 23? So we expect 20, but what's the probability it will range in between these two values? Then, of course, we're just going to use that formula. Here, we're going to take 18 and transform it into a z-score. We do that by taking this value 18, subtracting by the middle, all divided by, here, the middle times by 1 minus the middle, divided by n, which is 100, and take the square root. This gives us the z value, the z-score or z-value. Okay, here, then we can also convert this value, the 0.23. Okay, again, subtract it from its middle, and the standard deviation of the sampling distribution. So I get this z-score, I also get that z-score. If you go to your z-table, of course, you can find these two values. Here, this first value is in the row negative 0.5, and where it corresponds to 0.00, because I've got just negative 0.5. And I find this area. I also find this area by going to 0.7 and 0.05. That's going to give me 0.75, and I get this area. The difference between these two areas, of course, is this. So the probability that my sample will range between 18 and 23%, well, it looks like there is about a 46% chance that that happens. Okay, so there's using the z-scores. I can also, using the z-table, I can also find this using Minitab. Then again, I can just quickly go the two z-scores that I'm interested in here, negative 0.5 and 0.75. Okay, then I can go to calc, probability distribution, normal. Here I'm talking about z-scores, so the middle is 0, the spread is 1, and I'm looking for the probability of the cumulatives of things in column 17. Okay, so here, if you're not using your z-table, you can see that I can use Minitab and find the difference between the two areas there as well. Okay, so B says, what happens to p hat, the sampling distribution, if I change the sample size from 100 to 200? Okay, so everything remains the same formula-wise, except for here in the denominator I used to have a 100, and now I'm putting it at 200. As you can see then, my z-scores do change. I get a negative 0.711 and a positive 1.06. Okay, looking these values up on my z-table, here are the two values that you can practice if you want, looking at your z-table. And I find the difference in the probability is a little bit higher here. Okay, the probability of being between 18 and 23 goes up. The reason that it goes up is you have to think about this for a second. Okay, so here, if I only took 100 people, then the chance of being in between this and this, of course, is going to be a little bit smaller than if I took a larger sample. Okay, the larger sample, when I have a larger sample, I would expect my values to be closer and closer to the middle. Okay, so here, the probability of being in between here is going to go up just because it's going to capture more of the possibilities of that can actually happen. Okay, so I'll leave you to think about that for a few seconds. I think the important part is, of course, knowing how to convert your values into z-scores, how to look up these z-scores on your z-table, or how to use Minitab.